Assalamualaikum and very good day to all of you. So today we're gonna continue our part 2 in chapter 4 for radiation. There are two common scenario or mechanism happen in radiation. The first one called is radiation from surrounding to a small object. Okay, so for example, we are using oven. So oven is a surrounding, and it transfer the heat to, let's say, bread, for example. So that one is considered as scenario from surrounding to small object. Okay, and the second one is combined radiation and convection. All right, so I will explain in detail for combined radiation and convection in part 3. For today we're gonna cover part 2 only, which is radiation from surrounding to a small object, and for part 3 we will continue with the combined radiation and convection. Okay, let's begin with the phenomena of radiation to small object from surrounding. Okay, so this is the image to explain about how is the heat transfer through radiation from small object to small object from surrounding. So let's say the small object is labeled as 1 here inside it. Okay, and it is surrounded by another object, maybe like oven. Okay, so label as 2. Okay, so object 1, maybe we can say cake, so you're baking a cake. Okay, so as the heat transfer occur due to the difference in temperature. Of course, in the oven, the temperature of the oven is higher than the temperature inside the cake. So that's why heat transfer from 2 to 1, which means surrounding to the small object. Okay, so how much is the heat transfer due to the radiation happen in this case? Okay, so this is the equation that we can use to determine the heat transfer due to the radiation. Okay, so if you can have a look at this formula here, it's slightly similar to the one that we learned in part 1. However, here the terms here is changed a bit, where we have the difference in temperature between object 1 and object 2. Remember, object 1 is supposed to be the smaller object. Okay, in this case, the temperature of the cake at the beginning, and the T2 is the temperature of surrounding. Okay, so the temperature of the oven in this case. Okay, so here I highlight it again. The T1 is actually the temperature of a small object, and the T2 is actually temperature of surrounding. Okay, let's start with the example here. Okay, we have a small oxidized horizontal tube, okay, which is the diameter is given here. Okay, and also the length is given with the surface temperature is 588. Okay, so this is the temperature 1. Okay, which is placed in a very large furnace. Temperature as surrounding temperature is 1088, and this one is considered as T2 because it is surrounding temperature. And the emissivity of the metal tube is 0.6. This is the epsilon at 1088. Okay, and emissivity 0.46 at 588. So we need to calculate what is the heat transfer to the tube by radiation. And if I can give you some diagram, simple diagram, okay, for this question is it will be look like this, where it is the horizontal small oxidized tube, okay, which is placed in a horizontal direction. With the dimension is stated here, okay, and temperature, surface temperature 588 and surrounding temperature is 1088. Okay, so calculate the heat transfer to the tube, which is the heat transfer received by the tube from surrounding. Okay, let's take a look at the solution for this question. Okay, here we have the schematic diagram of the question. Okay, we have the tube which is surrounded by furnace. In this case, the temperature of the furnace at T2 1088 and temperature of the cylinder tube is 588. And we also have the dimension of the tube. And another one, we have emissivity at different temperature, in which that emissivity of the tube and emissivity of the surrounding. So which emissivity should we use? Later on I will discuss. Okay, here is the equation to determine the Q of the radiation from surrounding to a small object. So let's check it out. Each parameters involved in this equation. Let's start with the A1. A1 in this case is actually the surrounding temperature, the heat transfer area, okay, surrounding temperature of the object 1. Okay, so here is in the shape of the object 1 is actually in the shape of cylinder. Okay, so the surrounding area is actually at this layer, okay, the outside layer of the cylinders here. Okay, so that's why the formula here is actually pi dl. Okay, and emissivity. Okay, emissivity in this case we have to use emissivity 2, E2. Why? Okay, listen carefully. This is very important point. The emissivity that we should use in this equation should be the emissivity of the heat source. Okay, so in this case, which object or which part is actually as a source of the heat? When I say the heat source, that means it should be the object which consists with the high temperature. So in this case, the highest temperature is actually the surrounding temperature is at T2. So that's why the emissivity here, I use the emissivity 2. Okay, and next one is T1. Of course, T1 in this case is the small object at 588, and the T2 is actually the temperature of the surrounding. There we go. At the end, we got the Q is actually at 2130 watt and negative 2130. Yeah. So you might be, have a question why the value is negative. So listen carefully here. This is very important point. So it doesn't matter whether it is conduction, convection or radiation, how the value of Q become negatives. It is depends on which one is your reference point. Or for example, if the question asks you, how much is the heat transfer to the tube? That means the question wants us to consider the reference point is actually on the tube. Okay, so which object that you choose for the reference point? Okay. For example, there are two cases. Whether when you are considering the reference point, you have to identify, does the object receive heat or it release heat? Okay, when the object, if receive heat, receive means terima. Okay, so even though we have pepatah mengatakan tangan yang memberi lebih baik daripada tangan yang menerima. It didn't mean that those who accepting something is not good, but that pepatah actually very useful in this analogy. Okay, so I use this analogy a lot to make my student understand about this. Okay, if you receive heat, automatically the Q will be negative. If you release means you give something, automatically Q will be positive. So in this case, okay, which one is our reference point? Okay, the reference point in this case is actually our cylinder, the small object cylinder. Okay, so we know that the heat transfer in this case is actually from surrounding to small object. So if you are considering the small object here as your reference point, so by looking at the Q here, does the object receive or release heat? So in this case, it receive heat. That's why the Q here will be negative. Okay, but for example, like let's say that if your reference point is T1, maybe your the temperature of the object is higher. Let's say the temperature here is like 2000, okay, and the temperature of the surrounding may be like 100. So in this case, the heat will be moved from T1 from 1 to 2. Okay, so if you are looking at the reference point, on the perspective of reference point, here is our object 1, it release heat. So in this case, it will be positive. Okay, but in our case for this question, actually the small object receive the heat. That's why the value is negative. Okay, I hope you understand about that.
Okay, let's try with this quiz question. Okay, so the quiz is actually divided into two parts, which is A and B. For part A, we will discuss together in this slide, but for part B, you have to do it by your own. Okay, let's take a look at the question. Okay, so the question is stated that there's a loaf of bread with the temperature of the bread is at 373 and temperature of the oven is at 477, and the emissivity is 0.85, and the dimension of the bread, it is in a shape of rectangular solid where the dimension is given here. Okay, so the first question is question A, determine the radiation heat transfer, which means that we need to determine the Q to the bread, assuming that that is small compared to the oven. So we know that this question is actually in the case of a radiation from surrounding to the small object.
Okay, let's solve the question. So first of all, we should come up with the schematic diagram completed with all the information provided in the question. Okay, so here we already have information about dimension of the loaf, which is height, width, and length. Okay, and also the temperature of the loaf, which is 373, and temperature of the oven, which is 477.4. And lastly, the information about the emissivity is also provided. So we know that from the question asks us to determine the value of Q, where the heat transfer from radiation from surrounding to the small object. I repeat, why it calls from surrounding, because heat transfer from high temperature to low temperature. So temperature of surrounding is higher in this case, which is 477. So it transferred to the small object at 373. So we need to use this formula. Okay, let's check it out one by one, the information given in the question, whether it is completed or not to solve this equation in order to get the Q value. Okay, T1 and T2 is given. Okay, so the epsilon is also given, which is here, okay, and the sigma is just a Stefan-Boltzmann constant, and the area, well, the area is not directly given, but you can get the area from this diagram or from the dimension. Okay, so look at this carefully because it has a few surface area which need to be considered, because the area here is actually total surface area, okay, on the bread. Okay, so I make this table to make it easy. Okay, so for example, we have the area h times width. Okay, so before that, I will label this one is A1, A2, and A3. Surface area 1, surface area 2, and surface area 3. Okay, let's take a look. Where is the h height times width area, which is at this surface area? So A1 here. And don't forget that we also have another A1 at the other corner, at the other side. Okay, so we have A1 here. So that's why for total area, the first one at A1, we have two surface area with A1 value. So that's why I multiply with 2. So I got this total value with this for the surface with A1 area. Okay, for length time width. So for length time width, which is at this area, A2. Okay, so don't forget that we also have the A2 at the bottom part here. Okay, and again, A2 here, we have 2 units of A2 at the top and at the bottom. So that was why here I times it with 2, right? And last one, which is length times height, which is here, A3. And same again, you also have A3 at the other side. I don't know how can I, make it, how can I draw it, because it's at the other side, but I hope that you can imagine it because it's just opposite of it. Okay, so same again, it also consists 2 surface. Okay, so the total area for this is actually combination of A1 plus A2 plus A3. All right. So lastly, we just have to substitute all the value that we calculate just now in the equation. Okay, so we want to determine the Q, and we have the value for area already, and epsilon is given, T1 is also given, and T2 also given in this equation. And finally, we managed to get the Q, which is at minus 278 watt. Okay, just one quick reminder here, in which that the value here is supposed to be negative because our reference value here is actually the bread itself. That's why the bread received the heat, and in fact the T1 here is actually the temperature of the bread. So the bread is actually our reference point. Okay, so now we receive the bread, receive the heat, that's why it is negative. Okay. Alright, so we already complete question 1a, but not 1b yet. Okay, so according to the question 1b here, the baker decided to bake the bread in a shape of circular. Okay, so circular shape, where the diameter of the bread is given, which is 200 millimeter, and the Q also given. So we just need to know how much is the thickness of the bread. Okay, I will say that it is the height of the bread. Okay, so we already complete part A. Okay, and we know that since the shape is circular, so the dimension of the loaf in question 1b is no longer needed. Okay, so just discard about the information, and I just want to give you tips that it is in circular shape. So the question already gives us the diameter here. Okay, but what you need to determine here is actually the thickness, which is, I will say that is also as a high. okay, where it is the same as the thickness of the braid. Okay, so good luck. Alright, we already complete part 2 for chapter 4 radiation chapter. Okay, so we'll see you again in part 3.